when out in our markets, we often encounter contractors who are sold on one technology over another. Sometimes it's unit heaters, sometimes boilers, sometimes makeup air, sometimes 80/20 or recirculation. That being said, it's important to know as a rep what the distinct differences are between the technologies being offered and how Cambridge heaters compare to those particular technologies. Let's begin with unit heaters. Unit heaters are the most basic of all heating products. They're utilized by contractors. Engineers specify them because they understand the technology and how their redundant design makes them simple and easy to work with. However, unit heaters don't do anything to address indoor air quality issues. They also have a lower temperature rise, which means that there's more stratification in the space because the blowers also inside them don't move the air as much as a Cambridge S heater. Ask your contractor next time he specifies unit heaters to take a look at the job and see how many unit heaters he has to install. How many feet of gas line, how many feet of electrical, how many roof penetrations. He has to guarantee every one of those roof penetrations against leaking. Utilizing one Cambridge S or SA heater can easily replace up to 8 to 10 unit heaters in a single building. What does this mean? A lower installation cost, a lower unit cost, lower equipment cost, better air quality, less stratification, and lower overall operating costs. Boilers are one of the oldest forms of heating available in the market. Some of the technology dates back at least 200 years. And while huge advances have been made in boiler technologies and efficiencies, they're still one of the most expensive options for heating large industrial spaces. Understand that they require a lot of maintenance, a lot of repairs, pipes, traps, fittings, valves, all have to be replaced from time to time in order to keep the system running at its peak efficiency. Boilers also require a way to move the air, such as heat exchangers, which can be incorporated into other mechanical components like unit heaters or makeup air systems or even radiators. What this leads to is a large level of stratification in the space as well as huge maintenance costs over time. They're one of the most expensive things to install and also to maintain operation on a daily basis. Using Cambridge S heaters to replace boiler technologies is a most efficient way to both heat and destratify the space. With the highest temperature rise in the industry and discharge temperature at 160 degrees Fahrenheit, this allows the surrounding air to be also heated as well as fresh air brought in from outside at all times. This doesn't require additional components like piping and valves and other fittings, nor does it require heat exchangers because Cambridge S heaters are direct fire technologies. Recirculation systems or 80/20 systems. There's a lot of them out in the market, and what they're utilized to do is pressurize a space. So if your contractor is specifying an 80/20 or a recirculating system, in the next job that you're bidding on, ask them what happens when the dock doors open. Recirculation systems generally have a very low temperature rise, anywhere between 40, 50, 60 degrees. They also have a discharge temperature anywhere between 80 and 110 degrees. But that's a combination of the indoor air as well as the outdoor air they introduce. They typically operate 80% recirculation while bringing in 20% of the outside air. They're made to pressurize the space, and they're great for spaces where you have variable CFM needs, such as something that has a variable exhaust in the plant and also used to replenish that air on a constant basis. But they run constantly. One thing to consider, when the dock doors open in a facility, the unit goes to a full outside air mode. And what that means is with a very minimal temperature rise as described earlier, it has a hard time keeping up with the infiltration or the operating load of the building. So, talk to your contractor about what happens when those dock doors are open. What happens when they have a lot of dock door activity or door activity, which causes pressurization loss in the system. They're also not allowed to be used in Canada. no recirculating technology is allowed to be used in Canada alone. So keep in mind, if you're using a Cambridge S heater, you're not only bringing in 100% outside air, but you're also bringing in the highest temperature rise in the industry and the highest discharge temperature. With the ability to have a high nozzle velocity, these units are able to easily sweep and destratify the air, inducing over 10 times the amount of CFM they bring in. This alone allows the Cambridge S heater to easily outperform any 80/20 system on the market. Let's take a moment to talk about air rotation or air turnover. This technology has been around since about the 1920s, and the benefits of using air rotation or air turnover are that a single unit can be used for both tempered heating and tempered cooling within a facility. They often are a recirculating unit which draws a huge amount of air in from the surrounding space, brings it up through the tower, discharges it at the top. The problems with air rotation is that the motors are very large. The operating costs are extremely high because of the very large motors powering the blowers, and the fact that they are an indirect technology which gives them a lower temperature rise than any sort of direct fired technology. By utilizing either an M series or an S series from Cambridge Engineering, you're able to both temper the outside air as well as meet the building's required ventilation needs. Air turnover units don't really often do much to satisfy indoor air quality requirements within a building. So when you use a Cambridge S heater or a Cambridge M series makeup air unit, you're bringing in 100% outside air. With the heating technologies of the S unit, you're able to achieve a temperature rise and a discharge temperature of 160 degrees Fahrenheit, allowing you to easily sweep, destratify, heat the space for better creature comfort within the building. Let's now talk about direct fired makeup air systems. Makeup air systems are utilized to replenish exhausted air from process exhaust or from mechanical means. Their efficiencies are typically between 90 and 92%, and their draw-through design has a limited temperature rise because mechanicals are in the hot air stream. When a makeup air system provides air into a building, it's generally discharged through a very large plenum with low velocity and has no regard whatsoever for sweeping and destratifying the space, just replenishing the air. A lot of manufacturers recommend makeup air to heat spaces. However, with a low nozzle velocity, they're not able to sweep and destratify the space, much like a Cambridge S heater would. With the Cambridge S heater, our high discharge temperature and high temperature rise of 160 degrees Fahrenheit provides the best solution for heating a space while bringing in 100% outside air and also destratifying the environment. A good portion of our engineering presentation is devoted to comparing these two technologies, as well as using true BTU to compare the two technologies, a draw-through versus a blow-through. Now, agreed that there are perfect situations where both may exist in harmony in a building. However, if utilizing only makeup air to heat a space versus using a Cambridge S heater, the customer is not getting the most BTUs per CFM. So in closing, if you have any questions whatsoever with respect to related technologies, please reach out to your Cambridge Regional Sales Manager. We'll be happy to come out and sit down with your customers, contractors, and engineers to help explain the differences in technology and how Cambridge systems just perform better than most other systems in the market. Thank you.